In this example, we're going to see how we can make use of what we've learned so far um, to apply and find the projection as well as the length of projection. So if you take a look at this question, it's a very basic question. All right. You want to find the projection and length of projection of a vector on another vector, and you have learned earlier, all right, how to find it. So let me very quickly show you the what we've learned. Right, this thing should be in your mind. It is not in MF27. Yeah, so this one is not in MF27. All you will have to somewhat memorize it, and we've derived it earlier. So you can see this is your A and this is your B. So if you apply the formula, you look here, this is actually the projection. That means A dot B hat, which is the unit vector of B, all right, times B hat. So you can see projection of this, if you let this be A, let this be B, this is A dot B hat, B hat. All right, so after this is just very simple dot product, because if you can see, if you dot this, you get a number. All right, and usually what we will do is you can see this is a messy number, this is a messy number, but you multiply this with this, you get 1 over 21. So you get your hands dirty, you do this, and I'm sure you can get the answer. Now the next part asks you to find the length of projection. In the earlier section, we distinguished between projection and length of projection. Length of projection, essentially, if you look here, if you look at this formula here, the length of projection is actually the length of CF here, which is this length only. Not interested in the vector. The vector is direction. The length here is essentially just the magnitude of this vector. And if you can see, this formula here is A dot B hat. I'm going to show you very quickly. Length of projection is, this is A dot B hat. All right, and just bear in mind, just take note that it's a, sorry, I beg your pardon, this is a modular sign. I've explained earlier why there is a absolute value modular sign here. Now again, after this is all simple dot product, I will not go through very much, and you can get there. Now, when I solve this, I'm using this result here in the bottom, result number 2. Alternatively, actually, once you have found the projection here, you could have found the magnitude of this, the length of this over here as well. So alternatively, you could have applied the from here to here. This is an alternative. If you have already solved this, I don't think it's a problem. You can do it. But sometimes the question would not ask you for the projection first. They may just upfront ask you for the length of projection. Then I would strongly recommend that you use this method upfront. That's that.